In this video, I wanted to briefly cover graphing a few different types of equations. Okay, so the first one we're going to look at is just the basic absolute value equation. Now, one thing that we're going to notice here for the next two or three examples is that the methods we're going to use for graphing these are going to be very similar. There's a couple tricks for a few of them, but for the most part, it's going to be very similar. The thing I want you to take away from this video is the basic behavior of each type of equation, what each graph basically looks like. Okay, so for the absolute value equation, to see this, let's take a look at just the standard y equals the absolute value of x. So if you want to, you can plug in different points and make a little chart. Okay, and you probably should when you're graphing these yourself do more points than I'm going to here, but hopefully this will kind of demonstrate the idea. It's usually a good idea to start with the value x equals 0. So if we plug in x equals 0, we'll have y equals the absolute value of 0, and that's just going to be 0. So we know that the point 0, 0 is one of our points on the graph. Okay. If let's try 1, and usually the strategy is to plot 1 point to the left and 1 point to the right, and then keep going outward in either direction. So if we plot x equals 1, we'll have y equals the absolute value of 1, which is just 1. So we'll have the point 1, 1. Okay, let's see what happens if we plot y equals -1. Okay, we get 1 again. So the absolute value of -1 is 1. So if we go over to -1, we'll go up 1, and we'll have 1 here. And we can keep going, and what we're going to find is that it's going to look a little bit like this. Okay? As we go off in either direction. So this is the basic shape of your absolute value equation. So it's going to have a very sharp vertex. And the vertex is its lowest or highest point. We can think of it like that. It's going to have a very sharp vertex, and it's going to be going in a straight line off in either direction. Let's see what happens if we multiply uh, a 2 on the outside of the absolute value sign. So again, let's go ahead and make our plot. Okay. So if we plug in 0 again, we'll get y equals 2 times the absolute value of 0, which will just give us 0 times 2, which is 0. So again, that's going to be one of our points. 0, 0 is going to be one of our points. Let's try 1. So we have y equals 2 times the absolute value of 1, which is 2. All right, so we'll have 2. So we know that the point 1, 2 will be one of our points. Okay, and if we have maybe y equals the absolute value of 2 times -1, we'll get, again, 2, because -1, absolute value of -1 is 1, so 2 times 1 is 2, so we get -1, 2 is one of our points. Okay, and if you plot a couple more, what you're going to find is that the basic shape of the graph is going to look a little bit like this. Okay, so if you multiply a standard absolute value equation by a positive whole number, or by a positive number greater than 1, it's going to make the graph look a little skinnier. If you multiply an absolute value equation by a number between 0 and 1, it's going to make it a little bit wider. Okay, let's see what happens if we multiply it by a negative number. So we'll do our x, y. For 0, again, we're going to have y equals -2 times the absolute value of 0, which is just 0. So 0, 0, again, is going to be one of our points. Let's see about y equals -2 times the absolute value of 1. So 1 times -2, that's -2. So we're going to go 1, -2. All right, and predictably, if we do the absolute value of -1, we'll get -2 again. Okay? So if you multiply it by a negative number, it's going to flip it in the other direction. So it'll look a little bit like that. So this is a little bit about the basic behavior of a absolute value equation. Okay, let's take a look at parabolas of the form ax squared plus c. So I mentioned something about the vertex in the previous example. Here we have a good little trick for finding the vertex. If we have an absolute value equation of the form y equals ax squared plus c, we know that the vertex is given by 0, c. Okay? So for this one, it is of the form y equals 3x squared, or ax plus c, where c is just -2. Okay, so here c equals -2. So at the point 0, so we know that our vertex will be given by 0, -2. Okay, so we'll go 0 in the x direction and we'll go down 2. That's our vertex. The vertex is just the highest or lowest point of a parabola. Okay, so let's go ahead and plot our points. So what we're going to do is we're going to plot 1 point on either side of this. If we can, we'll do a couple more. So if we plot the point 1, we'll get 3 times 1 squared minus 2. Okay, and that'll give us, it'll just be 3 times 1 minus 2, or just 3 minus 2. So we'll get 1. Okay. If we plot -1, we're going to get something very similar, because we'll have 3 times -1 squared, which is just 3 times 1 again, minus 2. So we'll get 1 back. All right, now let's try 2. So if we do 2, we'll have 3 times 2 squared minus 2. Or this will be 3 times 4 minus 2. And 3 times 4 is 12. Okay, so we'll have 12 minus 2, so 10. So for the point 2, we're going to go up 10. Okay. This is growing very quickly. If we do -2, we'll have 3 times -2 squared minus 2. All right. I can write a little bit neater. 3 times -2 squared minus 2, which is just 3 times 4 minus 2. So 12 minus 2, again, is 10. So we'll go -2, 10. So we're going to have a really steep curve here. It's going to look about like that. So you notice these grow a lot faster than the absolute value equations do. And for the further you go in either direction, the faster it's going to grow. Okay, that's the nature of a exponential equation like this, right? It's going to grow very, very quickly. So if you square something, it grows faster the further you go. So let's take a look at something like y equals -x squared plus 2. So here our vertex is going to be of the form 0, 2. So here we're actually going to be going up 2. So this will be our vertex. Let's see what happens if we have -x squared. Okay. So if we plug in 1, we'll get -1 squared. Negative is on the outside of the squaring here, so that'll be 1. If you -1 plus 2, that'll just be 1. So if we go to 1, 1, that'll be here. And it'll look very similar for -1. Okay, so if we do -1, we'll get 1 again. Because we'll take -1 squared. So yeah, if we do 2, we'll have -2 squared plus 2. So we'll have -4 plus 2. So we'll have -2. 2. Yep, it's going to look a little bit like this. And same thing if we go 2 and we could do, sorry, we could do -2. We're also going to get back -2. Okay, so and if you want to check that, you feel free to check that for yourself. You can go through and confirm that that's the case. But the basic shape of the graph is going to look a little bit like this. So if you multiply your x squared by a negative number, it's going to flip the direction of the graph. Okay, so instead of your vertex being your lowest point, now it's going to be your highest point, and it's going to go in the other direction. Okay, so let's take a look at some other types of absolute value equations. Here we have y equals 6 times the absolute value of x plus 7. Okay, so to find your vertex, you just set all of this equal to 0. Okay, so if we set this equal to 0, we can we'll set 6 times the absolute value of x plus 7 equal to 0. We can divide both sides by 6, and we get 6 times the absolute value of x. We get the absolute value of x. Can't even write today. Absolute value of x plus 7 is equal to 0. And hopefully we can see that this is only going to be 0 when x is equal to -7. So our vertex for this is going to be, our vertex is going to be -7, 0, because we said our y value was 0. Okay, so if we go, that means we're not going up or down, but we are going to go to the left 7. Okay, and then what you can do is you can just simply plug in points. So if we wanted to plug in 1 to the right of this, we'd plug in maybe x equals -6. So if we have -6, the absolute value of -6 plus 7, that'd be the absolute value of 1 times 6. So we'll get 6 right here. So -6, 6 is one of your points. Okay. And one of the nice parts about absolute value equations is that they're going to have something called symmetry to them, which we'll discuss a little bit later this week. But then you can it's a pretty safe bet that you're also going to have this point as well. If we plugged in -8, we would get -8 plus 7, which is -1. And the absolute value of -1 is 1. So I have 6 times 1. So we'll get -8, 6. Okay, and you can keep doing this and plugging in points. And if you want to make your own chart and confirm that this is true, the further off you go, feel free to do so. Hopefully you get the idea of how this is going to look. All right, so now let's take a look at this one. Here we have y equals negative the absolute value of x minus 2. Okay, so let's go ahead and set this. Let's go ahead and set this equal to 0. Okay, we can get rid of the negative sign by just dividing both sides by -1, and we get the absolute value of x minus 2 is equal to 0. And hopefully we can see that this is only equal to 0 when x equals 2. So that means our vertex is going to be 2, 0. Okay, so we're not going up or down, but we're going to go to the right 2. Okay, so now what we can do is we can get some extra space here. We're going to move all this down to the next page. Okay, now what we can do is we can make a little plot for some points here. We'll actually do one this time. Okay, we'll do x, y. All right. So let's go ahead and plug in 1 point on either side. So let's plug in the point 3 for x. So that'll give us negative the absolute value of 3 minus 2. All right. So that's going to give us negative the absolute value of 1 or just negative 1. So for 3, we'll go down 1. That's one of our points. All right, let's try one to the left of it. So we'll put in 1. So we'll have negative the absolute value of negative 1 minus 2. Wait. No, I'm sorry. 1. Not 1. Not negative 1. 1 minus 2. That's going to give us negative the absolute value of negative 1, or again, just negative 1. Okay, so it'll look about like this. Okay, and you really only have to, with absolute value equations, you really only have to plot 1 point on either side because that'll give you your slope, and you can just connect the dots on either side and go out. But if you want to be more sure of yourself, you can plot more points if you would like. So if we wanted to plot, say, maybe one more point to the left, we can plot 0. Okay, so that would end up giving us negative times the negative 1 times the absolute value of 0 minus 2, or that would just give us negative 2. So 0, negative 2, that lines up. And you can keep checking on either side, and you'll find that this is the basic shape